Okay, let's do this practicing estimating limits on this side and slopes of tangent lines and getting tangent lines on the back side. So I'm going to do this on a calculator because it's kind of hard to switch from the camera to the screen though. But you can do this all on Desmos. I'll write kind of what it would be in Desmos and on the calculator. So I want to look at this equation. So on Desmos, I would type in f of x equals x squared minus 5x plus 6 over x minus 2. And then I would I would then say, let x get close and closer and closer to 2. So I'd be putting numbers like in here. I would say x equals 2.001. That's just a little bit bigger than 2. I'd let x equal 1.999. That's a little bit less than 2. And this should tell me, this should give me an answer for what that is or what that is. And I would pick something in between them that's pretty close to what this gets to. Now, if I did it on the calculator, I would type this into y1 and then just go to the table and get close. So here we go. So I'll put in y1. It's a fraction, so I'll put parenthesis, the numerator, x squared, subtract 5x plus 6, close parenthesis, all divided by parenthesis x minus 2, close parenthesis. And if I have my table set on ask, then I can go to table and I can delete what's in there and I can put in numbers close to 2 and 1.999. And it looks like we're getting close to a value of -1. So I think that's the limit. Now, this actually, I can show that it is exactly -1 because this numerator factors. So this limit as x approaches 2, this factors to x minus 3 and x minus 2 over x minus 2, and the x minus 2's would cancel, so I could just put 2 in there because there's not a problem anymore of putting 2 in, and I get 2 minus 3, which is the -1. This would have been easier just to simplify and then put in the 2. This one, you can't divide x into these very well, and we want x to go to 0. So again, I would just type this into either as f of x in Desmos and then pick x as close to 0, or on the calculator, I would clear this one and type in parenthesis 2 to the x minus 1, close parenthesis, divided by x, and then go to my table. And I don't want to be close to 2, I want to be close to 0, so I'll pick numbers close to 0. And minus 0.001. Those are both pretty close to 0, and I'm getting numbers that look like it's going to be 0.693-ish. Okay? On Desmos, if you write the equation in, I just was thinking about how that works again. Then you click on the gear to make a table for it, and then you can type in these numbers and get the values. So on C, I just got to go to my equation here, clear it, and type in parenthesis 3 sine 2 x, close parenthesis for the numerator, divided by x. And if I'm doing sine or cosine, I want to make sure my mode is in radians, and it is. And in Desmos, you have to make sure it is. And so then I'm going to look at my table, and now I'm supposed to be close to 0 again. Well, I've already got those in there, and it looks like it's going to be 6. Okay, now we're supposed to get close to 2 again. So it'd probably been good to do this one right after that one. Let's go ahead and do this one because it's getting close to 0. So I'm going to do that one next because these are already set to be close to 0. So I'm going to go to y equals and then say clear parenthesis 2 minus x, close parenthesis, divided by parenthesis x to the x minus 4, close parenthesis. And close to 2, I get this, and I get error on this side. Why do I get error on one side? Well, let's take a look at the graph. Stop. I'll go zoom 4. Oh, the graph doesn't really exist very well on the negative side of 0. So there's no limit here, because there is a right-hand limit. It looks like it's getting close to, what was it? Getting close to negative 0.66666. So there would have been a right-hand limit, but there's no left-hand limit, and so we will say there's no limit. Now this is the same function up here, but what's happening close to 2? Well, if we look at the graph again, it looks like it is getting close to 2, but it looks like there might be a hole there. So, but we can look at the table and use numbers close to 2. Second table, and close to 2 would be something like 2.0001. That's a little over 2. Little under 2 would be 1.999. And it looks like this is approaching a value of negative 0.148. Okay? That's this side. Oops, hit my camera. I'm going to give you a headache there while trying to watch what's going on. All right. Now, let's do the back side. A few more steps on this. Now I want to know what the slope is. So now we have to use the definition, which is the limit as h approaches 0 of f of a plus h. And so I'll write it with I'll write it with a plus h minus f of a over h. That's how we'll get the slope, f prime at a. And we need the slope there to be able to write the equation. So to do this, I'm going to type in the function in y1. So clear, and the function is 2x squared minus x. And I don't know why my calculator quit doing pretty print, but anyway, 2x squared minus x. That's the function. And then I'll come down here and do it in 3 so you can see the difference here. Now I got to do the numerator, which is f, or y1. And to do that, I push vars, y variables, function y1 at a plus h, but a is going to be 3. So I'm going to put parentheses 3 plus h. Okay, I can do h on the calculator. Uh, it'll be easier if I just put an x in place of the h. So now I got to remember that x is two different things. There's an x in this function, but now I'm using x for the h. So I'm going to type in 3 plus x, close parenthesis, minus f, which is y1 on the calculator, vars, y variables, function y1 of 3, because a is 3. And that's my numerator, so I got to close my numerator, divided by my denominator, and I'm using x for the h here. So now when I go to find the limit of this, I'm going to be letting x get close to 0. That's not making this x close to 0, it's making x and this close to 0. So I'm going to go to second table, and I'm close to 2 here. I need to be close to 0, so 0.0001 and negative 0.0001. And I'm going to ignore this. It's looking like the slope that I have in y3 is about 11. So the slope, f prime at 3, the slope at 3 is 11. Again, I could have typed this in as f of x into Desmos, then type this in Desmos with a 3 there and a 3 there, and h or x here, like I did here. If I put an x there in Desmos, then I could go to second table, or hit the gear on this, and give me a table, and then I can type in numbers close to 0, should get 11 for the slope. So now I have to write the equation. So the tangent line would be y equals 11x, because that's the slope, times x plus a y-intercept. Well, I'm looking near 3, so if I put 3 in here, 2 times 3 squared, 9 times 2, 18, minus 3 is 15. So the graph is going through the point 3, 15, and has a slope of 11. So I want to write an equation of the tangent line. So I put 3 in here, and I get 33, but I'm supposed to get 11. So I'd have to subtract 22 from 33 to get 11. And so here's my equation of the tangent line. Okay, let's do the same thing here. So I'm going to do pretty much everything's going to be the same, except I'm going to go and change my equation to clear it and put in 1 divided by 2, got to put parentheses 2x, close parenthesis. And I want to be at minus 2, not at 3. So I got to come down here and change the 3 to negative, insert 2. And over here I got to make it negative, insert 2. Now the equation's right, and the quotient limit definition is correct, and so I just have to make x close to 0 on this and look at y3. So I go to the second table, and it looks like the slope is negative 0.125. So m is negative 0.125, and the equation would be minus 0.125x plus some b. Now I need to put 2 into the equation. y1's the equation, so I can just come down here and put 2 in, and it says it's 20.25. So So this equation goes through negative 2 point, I put in 2. I got to put in negative 2. Negative 2, it goes through negative 0.25. 5. So I have to make this equation go through that. So if I put negative 2 here, negative 2 times negative 1.25 is positive 0.25, and I'm supposed to get negative 0.25. That's a negative quarter. This is a positive quarter. A positive quarter plus something is supposed to be a negative quarter. I think negative a half added to a positive quarter ends up a negative quarter. And so there's the equation of the tangent line. And I could actually draw the graph of this and this line, and this line should touch this graph at negative 2 and be tangent to it. And let's do the final one. So I'm going to go back and change my function to square root of x there's my function, and I'm looking at 4, so I got to go into my equation and say I'm looking for the slope at 4, and delete the minus and put 4. Now I'm looking at it at 4, so I want to look close to 0 on y3. So I go second table, and those two are close to 0. This is slightly above and below, and slightly above, or below and by above. Anyway, I'm getting a slope of 0.25. And then I got to know what it's at 4, so I'm going to put in 4. At 4, square root of 4 is 2. So this graph goes through the point 4, 2. And so now I got to write the equation of the line that goes through 4, 2 with a slope of 0.25. So it's y equal 0.25 times x plus something. And if I put 4 in here, a quarter of 4 is 1, and I'm supposed to get 2, so it must be plus 1. Let's just check this one. So I have the square root of x in here. I don't need to see this on a graph. So if I graph this, looks like that. And out here is 4, and I'm trying to get a tangent line there. And it says the slope should be 0.25 plus 1. So I go to y equals, I'll just put in another one here. I'll put it in 0.25x plus 1. And if I graph that, I should get a line that's just touches at 1, 2, 3, 4, just touches there, and it has the same slope as the blue curve there. And that looks pretty good.